Hello everyone. In this video lecture, we will study the next type of induction motor rotor, that is phase wound or wound rotor or slip ring induction. So rotor of this type of motor has a three-phase winding similar to the stator winding. So only case is that we take out the three-phase winding connections from the rotor and connect it to the external resistance or rheostat with the help of slip ring and brushes. So the slip ring is mounted on the shaft, and on that slip rings, that is slip rings is rotated uh, when the shaft is rotated. But on that slip ring, we put a carbon brushes press along its surface so that when shaft rotates, slip ring rotates, but the current induced in that rotor is collected by this brush continuously and fed into the external resistor circuit. So we use a slip ring. That's why it is also called as a slip ring motors. So in this diagram, this is a shaft. This is a rotor conductors and make a three-phase winding, and this is a slip ring. On that slip ring, we uh, press a carbon brushes in order to collect the current induced in the rotating rotor. So phase wound rotor consists of slotted armature. It consists of laminated cylindrical core and carries three-phase winding similar to the one on the stator. So rotor winding is uniformly distributed in slots and usually a star current. So the open ends of the rotor windings are brought out and joined to a three insulated slip rings mounted on the rotor shaft with one brush resting on each slip ring. So we take out the three connections from this rotor winding and connected to the three slip rings. So these three brushes are connected to a three-phase star connected. So at starting, the external resistances are included in the rotor circuit to give a large torque, a starting torque. So these resistance are gradually reduced to zero and motor runs up to the speed. So in order to increase the starting torque, that is in case of squirrel cage induction motor, there is a limited starting torque. So in higher starting torque application, we add an external resistance. So we use a slip ring motors to fulfill that high starting torque requirement. So principle of operation of three-phase induction motor. So likewise, if we this is a stator area and this is a rotor area, and rotor conductor are shown. So when the we give the three-phase supply to the stator winding, it will create a magnetic field, which is a rotating one. It is automatically rotated. That's why we call it as a rotating magnetic field. And that speed at which this rotating magnetic field is rotates, that we call as a synchronous speed. So there is a formula for synchronous speed, that is ns is equal to 120 f divided by p. So ns stands for synchronous speed, P stands for number of poles, and F stands for frequency. Suppose if we have a frequency of 50 hertz and stator consider that motor consists of 4 poles. So 120 into 50 divided by 4, we get which gives 1500 rpm. So that's 1500 rpm. In this example, it is called as the synchronous speed. That is the speed at which that rotating magnetic field rotates. So at the starting, these rotors, bars and rotor conductors are stationary in position, that is in steady position. When we give the three-phase supply to the stator winding, it will create a rotating magnetic field. So according to Faraday's laws of electromagnetic induction, so there is a relative motion between magnetic field and stationary conductor, or there is a relative field between basically magnetic field and rotor conductor. So in this case, the magnetic field is rotating one, and at the starting, the rotor is stationary. So there is a relative motion between these two, that is magnetic field. There is a relative speed between magnetic field and stationary rotor conductors. So according to Faraday's laws of electromagnetic induction, there is a EMF induced in that rotor conductors. So the rotor conductors induces EMF. So this rotor circuit is closed circuit. So the current starts flowing in that rotor circuit. So when current starts flowing, there is a induced means there is that current, that rotor current creates the own magnetic field. So on after that words there is a two magnetic field, that is stator magnetic field and rotor magnetic field, which interacts, these two magnetic fields interacts with each other and create a force in direction to the rotation of stator. So this is how the this is how the induction motor rotates. So for example, one question in mind, that if that is why induction motor, why three-phase induction motor never runs on synchronous speed, which means that why the induction motor rotor never rotates at a synchronous speed, which synchronous speed means the stator magnetic field which rotates at particular speed, that speed is called as the synchronous speed. So why this rotor of induction motor never runs on a synchronous speed? So I will explain now. So if we suppose rotation of is stated at 1000 rpm, for example, that synchronous speed is 1000 rpm. 1000 rpm means this, if we give a supply to the stator winding, they there is a magnetic field is created. That magnetic field rotates at synchronous speed. So in this case we take a 1000 rpm, 1000 rpm as a synchronous speed. If we somehow rotates the rotor, if we somehow rotates the rotor at synchronous speed, means by external means, if we by external means by using a different motor connected to the rotor and rotates that rotor at a 1000 rpm, in this case synchronous speed, means stator magnetic field is also at same speed, that is 1000 rpm, and rotor is also a 1000 rpm. So both the both the condition, that is both the that stator field and rotor rotates at the same speed. So there is this both looks like to the steady in position, that is because it will rotate at same speed, so it will looks like to each other at a steady position. So there is a no relative motion between them, so that there is a no flux getting, so there is a no EMF produced in that rotor conductors. And there is a, if there is a no EMF generated in rotor conductor, then there is a no flux create, there is no current flowing. If there is a no current, then there will be no flux created by the rotor conductors, and there is a no flux in rotor conductors, then there is a no force created in the rotor. So that's why this three-phase induction motor never runs on a synchronous speed. So when a three-phase stator winding is energized from a three-phase supply, a rotating magnetic field is set up which rotates around the stator at synchronous speed. So the rotating field passes through air gap and cuts the rotor conductor, which as it stationary. But due to relative speed between rotating flux and stationary rotor, EMFs are induced in these rotor conductors. Since the rotor circuit is short-circuited, current starts flowing in the rotor. So this is a theory related. So difference between squirrel cage induction motor and wound rotor induction motor, that is slip ring induction motor. So in cage induction motors, construction is very simple. In slip ring induction motor, construction is very complicated because we have to add external resistance, slip rings, and brushes, etc. So in squirrel cage induction motor, rotor consists of bars which are shorted at the end of with the help of end rings. And in slip ring induction motor, rotor consists of three-phase winding similar to the stator. So in squirrel cage induction motor, external resistance cannot be added because rotor is already shorted at the with the help of end rings. But in this case, that slip ring induction motor, resistance can be added externally. In squirrel cage induction motor, slip ring and brushes are absent. In slip ring motors, slip ring and brushes are present to add external resistance. So the construction is robust and less maintenance required in squirrel cage induction motor. But construction is less robust and frequent maintenance is required because of the presence of brushes. The starting torque of squirrel cage induction motor is low and cannot be improved, but due to presence of external resistance, by varying the value of external resistance, we can adjust or fulfill the high starting torque requirement of that particular application. Next is speed control of rotor resistance method is not possible in squirrel cage induction motor, but speed control by rotor resistance method is possible in slip ring induction motor. Rotor resistance starter cannot be used, but in squirrel cage induction motor, but rotor resistance starter can be used in slip ring induction motor. So rotors are very costly in squirrel cage induction motor. Slip ring rotors are cheap. Next is rotor copper losses are less in squirrel cage induction motor, hence higher efficiency. But in case of slip ring induction motor, rotor copper losses are high, hence less efficiency. And squirrel cage induction motor used for lathes, drilling machine, fans, blowers, water pumps, grinders, printing machines, which requires low starting torque. But in case of slip ring induction motor, the application that is this type of motor used for lifts, hoist, cranes, elevators, compressor, etc., which requires high starting. So in next lecture, we will study the next motor that is synchronous motor. Thank you.